Hello ladies and gentlemen, so today we're going to look at logarithms, which is a new type of notation to help us solve for x. Some needs: you're going to need a calculator, and it's going to need to be a scientific calculator today, and then your notes of course as well. So, why are we learning this? Consider crime forensics. So, have you ever watched one of those murder shows and they're saying, well, this person has a trace of nut in their blood, so that puts his approximate death at time. Well, here's a possible solution. According to chemistry reports, the victim had traces of aspirin in their blood. Aspirin is known to decay at the rate of 20% per hour in the human body. So a friend saw the victim take aspirin, or 500 milligrams, around 4 p.m. What is the approximate time of the crime? So this is an actual thing that could happen in real life. So let's think about the decay formula that we've used recently. So originally, we know that our victim took 500 milligrams, right? 1 minus in the rate was 30 or 20%, excuse me. So that'd be 0.2. We don't know how long since they took it though, but we do know at the end of time, they had 300 milligrams left in their blood. So what we need to do is we need to figure out how could we get to that t. So normally we would have divided by 500, right? Get rid of that 500. So it would be at 3/5 over here equals 1 minus 0.2 to the t. Well, 1 minus 0.2, that is 0.8, 0.8 to the t. We can't get to the t. We can't get to this. We can't solve for t right now. So logarithms is going to help us do this. So here's some new notation you're going to want to get down. So exponential form is when you have a base, an exponent, and a value equal to a number. The log form allows you to get that exponent and get it alone. So this 2, this big 2 right here, he's going to become the little 2 on the base of the log. Big 16, he's going to go right there. And that 4 is going to become the new answer. Just like that. So it's going to be log base 2 of 16 equals 4. So let's try the next ones here. We got log. Here's my base. Base becomes the new base of the log. So I'm going to have a little 10 down here by the log. So that's the base of the log. Your exponent becomes the new answer. Alright? Exponent, answer, both vowels. Good way to remember that. And then the answer is now the new middle number. So right here, this big number right there. Alright. Let's try one more time. Log base. Base over here is 3, so that's my new base on my log. Exponent becomes answer. Exponent became answer. Answer becomes middle. Alright? It's going to take us a little bit time to get used to moving what everything goes. So this lets us isolate an exponent. So right now we would have log base 3 of 9 equals, and we don't know what the answer is, right? So this would be technically an x. We'll just call it x there. So let's figure out what this is going to be. So this would be 3 to the x equals 9. 3 to the x equals 9. Base, answer, middle. So what does x have to be? What 3 to what power will give you 9? You are right. X would have to be 2, because 3 squared equals 9, right? What about this one? If we would have an x here, we would have 4 to the x equals 16. What does x have to be if I want to know 4 to what power equals 16? 2. 2 again, right? What about, this is going to also be an x, we have 4 to the x equals 2. You're saying, well, Miss Marsh, I don't know if I know what that would be. 4 to what power equals 2? I know 4 and 2 are related by a square root, right? Square root for a fraction exponent, 1/2. 4 to the 1/2 equals 2. Try that in your calculator, it'll work. I betcha. What about 3 to the x equals -1? You could try this as much as you want. You could try to find an x as much as you want. This is not possible. So this would be a no solution problem. Can't get a negative exponent or a negative answer by any means. Now you're saying, well, can't we just do this on our calculator? Yes, but your calculator has a little bit of limitations. There are infinitely many logs you could do. You could do log base 3 of 8, log base 3.1 of 8, log base 3.11 of 8, as many logs as you want, but most calculators are only programmed to calculate logs with a base of 10. This is known as the common log. So your calculator, if you find your log button, which we'll have to find on tomorrow, they will only be log base 10. Now, some calculators have started coming out that you can find a base programming. If that's the case, good, you can use that. If not, you're going to need to use this formula. So using your calculator, here is the change of base formula. This is to calculate a log on the calculator. You're going to go log base A of B. You're going to say log of B over log of A. So big, go to top, little, go to bottom. So log of B over log of A. All right? So you're going to want to make sure you get that down in your notes for a fact. You're going to be using that on your calculator most likely. So let's use the calculator to help find some value, shall we? So what you're going to type in your calculator. This is that change of base formula right here. So you're going to want to type log of big, 81, over log of 3. So log of 81 divided by log of 3, that is 4. So what we know, that would be 3 to the 4th equals 81. That is the case. If you try that on your calculator, you will get that same, you will get 81. What about this one? We're going to have log of 10 over log of 2, which does not come out nice by any means. It's 3.32. So that means base 2, 3.32 equals 10. Approximately 10. Not a perfect 10, but approximately. This one, we're going to go log of 1 divided by log of 10. You will get 0 for that one. Makes sense, though. If you go 10 to the 0, that does equal 1. Because remember, anything to the 0 power was equal to 1. Log of 2 over log of 64. That's 1/6, or 0.16666, I believe. This means 64 to the 1/6 power equals 2, which is the case indeed. And then log base 8 over log base 3. This is not a nice number. It's 1.89. So 3 to the 1.89 equals 8. So basically tomorrow what we're going to be doing is we're going to be converting from exponential to log and log to exponential and then solving some. We'll go over quite a few more. We'll work together as a class to go over a few more. But that's the end of the video. This is Miss Marsh signing off.